Hi, I'm Molezion from Richardson RFPD.
And I'm Tholen from NextGen RF Design. Today we're going to be demonstrating the Byte Pipe X9002 system on a module. This SOM consists of a Xilinx Zinc UltraScale Plus SoC and an ADRV 9002 from Analog Devices. It's a fully incorporated software-defined radio suitable for rapid prototyping, design evaluation, or end product integration. So today we're transmitting a 9 megahertz wide LTE signal. We're going to show you a short video that demonstrates digital pre-distortion.
In this presentation, we are combining the Byte Pipe X9002 system on module with a Radio Carbon RF front end. And I will be demonstrating digital pre-distortion using a 10 megahertz bandwidth LTE signal. We begin by resetting the device. We will use the NextGen RF SDK command line interface to set the transmit waveform parameters. Using the command ls, we can view a list of IQ files stored on the file system on the SD card. I will select Crest Factor Reduced 10 MHz bandwidth LTE waveform and load it into the transmitter. Next, I will set the transmit attenuation settings and enable the transmit boost function to set the output power to 2 watts. Now that the transmitter is set up, I will save this trace to capture the transmitter performance without pre-distortion. We can save that as the green trace. Next, we'll set up digital pre-distortion by enabling DPD and turning the transmitter back on. As you can see, the transmitter is now being corrected by the digital pre-distortion, and the intermodulation products are reduced. That concludes this demonstration. Thanks for watching.
Next, we'll have Danny talk about the Radio Carbon RF front end.
This Radio Carbon platform contains a complete RF front end. It contains a single channel receiver as well as a single channel transmit lineup. The user can actually operate this front end module in both standalone mode or, as we have shown here, integrated with the Byte Pipe SOM. If the user is actually using it in standalone mode, they will come in at the antenna RF port. There's essentially the signal goes through a circulator, then a TR switch, and then through an ultra low noise amplifier, followed by a second stage amplifier with bypass. Those are both from Gorilla RF. There's also a selectable tunable bandpass filter from ADI that gives the receiver performance very excellent receiver selectivity. On the transmit chain, we actually have 3 stages of cascaded amplification. We have a pre-driver from Gorilla RF. It has a driver as well as a final stage amplifier that's designed using high performance GaN transistors from Wolfspeed. The final stage amplifier is actually designed in a balanced hybrid configuration, so we have input hybrid couplers as well as output hybrid couplers. That signal then goes through a directional coupler and then out through the circulator to the RF port. From a performance standpoint, we're getting roughly 44 to 45 dBm of PSAT performance with roughly about mid 40% efficiency at saturated power. But again, as we're showing here, this module can actually be operated in a linear fashion with an LTE signal. So it's great versatility with the Radio Carbon module. In addition to the hardware that we have shown here, we actually have a very feature-rich GUI that's available for the user. This GUI will allow the user to actually configure the PA, both for biasing and also for doing on and off sequencing. We have many other features that are built into the GUI that allows you to monitor the gate to source voltages, the drain currents, real time. There are also temperature sensors that are actually placed very close to the PA, so you could do really good thermal analysis and keep an idea of what's going on thermally with your PA. There are many features that are available both on the hardware, the contents of the board, as well as the feature-rich GUI. So for more information, visit us at richardsonrfpd.com or nextgenrf.com. Thank you for watching.